Okay, so now that we have defined the operation of multiplication and all the different ways that we could look at it, let's look at some of the properties. And these terms should be familiar only because we have looked at it from an addition perspective. So the first one that we're going to look at is closure. And recall from our addition part that closure means when you do the operation, the result is still in the set that you're considering. So the set that we're considering is whole numbers. So when you add, when A and B is a whole number, when you multiply A times B, or just write AB, is this another whole number? Right? So what you need to see is if you can multiply any whole numbers to not get a whole number, right? So in order to invalidate this, you would have to find a counter argument, which there doesn't exist one. And normally in class I would do the, discussions and trying to come up with examples. But since we don't have that interaction, it'll be a little front-loaded with information. So the closure property does hold, so for multiplication of whole numbers. The next thing that we're going to look at is commutative property. So for addition, we looked at it, and addition was commutative. So you could change the order, and it would yield the same sum. So for multiplication, it holds as well. So we could multiply A times B is the same thing as doing B times A. So multiplication is commutative. Next one that we looked at in addition was associative. And you can think of associative, like I mentioned before, was with regards to grouping. So when we have ABC, ABC, we're trying to see if we multiply the first two and then we multiply the second two, or we group it together, does this yield the same result? And for multiplication, it is associative. So we could multiply A and B first and then multiply by C, and that result, or the product, would be the same thing as multiplying B and C first and then multiplying by A. So going back to addition, the additive identity was 0, right? So if we did A plus 0, or the other way around, so 0 plus A, it equaled A. And now for multiplication, we have a multiplicative identity. So multiplicative identity. So we're trying to find out what can we multiply to A to get itself. And the result is 1. So 1 times anything is itself. So 1 is called the multiplicative identity, and when we multiply it on either side, so A times 1 is equal to 1 times A, which is itself. And that's why we call it the identity property of multiplication. And there's no other number that will make this work other than 1. So it's unique in that sense. And last but not least, we have zero multiplication property of whole numbers. So let me write that down. Zero multiplication property, and all of these are of whole numbers. And what the zero multiplication property states is for any number A, any whole number A times 0 is equal to 0, and it doesn't matter which order you do it because multiplication is commutative. So zero multiplication property just states that if you multiply any whole number by 0, the result that you get is 0. And let's look at one more thing. So now at this point we're going to combine multiplication and addition. So if we have 3 whole numbers, A, B plus C, so say we're adding B plus C and then multiplying by A, the distributive property states that you could do it in this order, or you could multiply first. So A times B, and then A times C, and then add it together. So I'll start off the next video with the distributive property and making a little bit more sense of where that comes from and why that happens.